Okay, so please. Okay, okay. Uh, all right. So please, I want us to do a quick walkthrough of this to get a clear understanding of how we are going to perform these two types of descriptive statistics, how and when to choose them. As your journey as a data scientist or as a data analyst, you are going to have a serious problem with statistical interpretation. So going over, we started asking about the topic, and the topic for today and tomorrow is on data aggregation and descriptive statistics. So with the data aggregation, Evelyn said gathering data from multiple sources. And Casey also assisted us. He also said that descriptive statistics simply means, or descriptive statistics help us describe and summarize or summarizes our data. So to continue from their inputs, I said, if we are gathering data from many sources or gathering data, putting data together, and knowing how to describe and summarize our data to make a statistical meaningful from data, then these three types of descriptive statistics have important role to play in our data interpretation. We've already looked at basic statistics in the previous weeks. So this is a built up um, lesson on that. So the first thing we are to look at whenever you pick a data or whenever you are analyzing the data, you want to establish or perform descriptive statistics. First, look at your measures of frequency. And the measures of frequency, we said we are looking at number of times a specific, so sorry, I made a mistake here, a specific value repeats itself or appears in our data. So taking our male column for an example, we can see that, or going through it, we realize that the zeros were 4. So meaning that the zeros are many than any other value over here. During our GHS and SHS days, we used to do the tally table. You write 4 tables like this. 1, 2, 3. No, don't know this. 1, 2, 3, 4. Then you use the last one to cross this one, making 5, right? So we were doing something called frequency distribution table. It's similar to this one. But to do advanced statistics or perform advanced statistics on your data or interpret your statistics on data, then if the zeros are repeating itself more, then what is the meaning on our data? So I told you to write it down. We are going to look at the why, to not complicate the training section, to confuse us. Let's put that question down and look at what goes into the data when you are trying to perform or establish statistical interpretation on any. Now, after I've been able to identify my measures of frequency, how many times a specific number repeats itself, then, okay, what is happening at the center of my data? So be curious enough to look at what is happening at the center of your data because it is very important. And to look at the center of your data, you are going to look for just a single value. That's a single number. When you start doing visualization, you might not see a number. You only see points, data. So you are also going to look at that single point, that single data, to use that as your center. Hello? I think my internet is unstable now. Please, am I audible? Hello? Hello?
Yeah,
All
yeah.
right. Okay.
Yeah, it's okay.
So after the center
Hello,
is
yeah, 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 it's okay.
after the center is identified, then we look at, okay, now we are using 5 over here, right? We don't want to confuse ourselves with the columns over here, the male and the female over here. But we are assuming that looking into a data, maybe we are having, or let me set an example here, um, 2, 3, 2, 4, 5, 7, 8, 9, 4. How many? 1, 2, 3, 4, 5, 6, 7, 8. So 9. No, this should be 2 again. So now we can pick 7. The 7 as our center. And knowing 7 is our center, what we are going to do is, okay, if the 7 is our center, no. If the 7 is our center, please I'll call you. If the 7 is our center, then what is happening at the left and at the right side of the 7? As simple as that. So knowing the center 7 here, now the 7 becomes our central tendency. The 7 here, the 7 becomes our central. So I'm using CD as central tendency. Okay, if 7 is our central tendency, okay, what does 2, 4, 5 mean at the left? And what does 8, 9, 4 mean at the right? What are their importance? What are their impact on our data? How are we going to explain? Okay, if 7 is at the center of our data, then I think 2, 4, 2, 5 are small than 8, 9, 4, 2 if we are to put them together. And so what is what we are going to look at. So the what behind if 7 at the center is what we are going to look at. So after the center is being identified, and always remember that we need a single value to do that. That's just 7. After that one is found, then we look at what is happening at the right and left side. Left. Oh, please, my keyboard. So at the left side, of your data or of the center. So now we are all on the same page. So I'm using the technical term of the central tendency. So looking at the left and the right side of the central tendency, then we are looking at our measures of variability. And variability simply means spread or measures of, let me put it here, measures of spread. Okay, so how are these values here spread from 7? So if we take 7 over here, now let's take from 2 to 7. From 2 to 7, we have 3, 4, 5, 6 over there. From 4 to 7, we have 5, 6 before 7. From another 2 to 7, we have from 3 to 6, and from 6 at over here between 5 and 7. But from 7 to 8, just 1. From 7 to 9, 2. From 7 to 4, 3. And from 7 to 2, 5. The question is, how are these data points spread from each other and from the central tendency? And our central tendency is always going to give us our mean. Somebody will ask, then what is the median? We shouldn't confuse ourselves now. We are looking at what is happening at the center, what is happening at the right and the left side of our data, when to perform central tendency and when to perform measures of spread. So now, the moment we are able to identify our center, now does the center means the mean or the average just the mean at the center and that's it. No. After you've been able to identify the center, three things will also come to mind over here. And these are types of central tendency. So these types are the mean, the mode, and the median. Each of them has its when, where, and why to perform them or establish them on the data. Let's put that one aside for tomorrow so we can confuse ourselves over there. Now, after we've been able to establish our central tendency, either the why of reusing the mean based on a particular reason, based on a particular outliers being found in our data. So please, you can put it down if it's your first time hearing outliers or outlier. Is it A or E? Please check the spelling for me. I think it's E or something here. Outliers or A or outlier. If there are more outliers in our data, which of these measures of central tendency should we perform, establish? We are going to look at that, but it will confuse us today. Now, after I have been able to identify why, what, behind using any of these to find your middle number or your single value at the center, then you can come and look at what is happening at the right or the left side of your data. These three things should come into mind. Either you are going to look for your range, your standard deviation, or your variance. And knowing when to use the range is also based on a factor. And knowing when to use the standard deviation is also based on a factor. And knowing when to use the variance or the variance is also based on a factor. To add little to this one, anytime you want to use your range to look at what is happening at the left or the right side of your data, we are also going to look at three main things over here. Your first, second quarter, but I don't want to eat into that this evening. So you can read around it, get a fair idea. So tomorrow we will do something deeper than what we are doing today. And tomorrow, if we are to establish mean, mode, why, how to merge your outliers, how to clear your outliers, is going to be very confusing. So please, so far, if you have any question, if you are not getting anything, please let me know so we can all help each other. We can all help each other. So Evelyn, Hayford, Richmond, Festus, any other person. If you have any question to ask, please do and ask. Because I have so many questions for you. So no question for me. Is it difficult? All right. So Evelyn, can you hear me? Hello, Evelyn. Evelyn. Ayan.
Yeah.
Okay. So
Yeah.
Evelyn, this my first time as an analyst. I've been sent to Center for Analytic Services to help them make meaning from their statistical analysis, right? So I am picking a data from here. No, let us understand ourselves and generate a data for ourselves here. So I'm looking at these figures 2, 4, 7, 8, 4, 2. They are just random numbers, right? Random numbers. Okay, let's use ages. So, so teenage pregnancy. Mm. And unmarried women. Unmarried women. Let's take unmarried women for example. So in Ghana, our constitution states that a lady is matured from age 18, right? So this is Opanini Alliance community. So age 18, 19, 18, 20, 20, 21, 22, and maybe 27, 27, 29, 34, no, 30, 32, 33, oh, 32, 30, no, 33, 35. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. So now we have 13 unmarried women. 13 unmarried women in let's say Winneba or Legon. Let's use Legon. So 13 unmarried women in Legon. And these people, their ages are ranging from 18 to 33. First, we are going to find our mean. And finding our mean, we are not going to do any calculation. And to find a mean is to first, what do we need to do? We are not doing any calculation over here. But to find a mean is the total number over there. So the total number over there over, so a sum of the total number over here, our sum of the total number over here divided by the numbers over here. So 13, right? So the number is what? 13. Will give us maybe an average of, okay, so let's do it and see something. So 18 plus 19 plus 18 plus 20 plus 21 plus 23 plus 27 plus 29 plus 32 plus 33 plus 25 divided by 13. Coming. Okay. Hey, no, this wrong. Let me put this in a bracket and see. Okay, so we are getting our average to be what? 20, right? So either 20, no, not up to 21. So our average number here is 20. So our 20, average number is 20. So if we are to rearrange this age, so we have 18, 18, 19, 18, 19, so 18, 18. We are not finding the mode, right? But I just want us to do something here. 18, 18, 19, 20, 21, 23, 27, 27, 27, no, to 29, no, okay, 29, no problem. 20, 33. So here we have 24. Oh, no, 24. Okay, 25. 25, 32, and okay. So let me take this one here as our mean because that's the average we got. Oh no. Yeah. Okay. So this is the average we got, right? The average here is 20. And if we rearrange our data set or our data from smallest to the highest number or the highest age over here, this is where we are getting our center. Now, our center of the data here is 20. Now, what is happening here at the left? What is happening here at the right? Very confusing. Evelyn. Hello, Evelyn. Evelyn.
Yeah.
Please, can you see something?
Yes.
Can you see something? Yeah. Do you understand something here? Hmm? Do you understand something here?
Not really.
Not really, right? So, Kingsley, what do you understand over here? Kingsley, Kingsley. All right. Who else? Richmond. Can see this in your networks. Richmond. But please, can you guys hear me? Can you guys hear me? Hello? Hello?
Yeah.
Yeah. So
Yeah.
now that we've been able to identify our middle number, right? Now we have something called skew, skewness of data, So we have right skew and left skew. Left skew. Left skew. Or often you will hear our data is imbalanced. Imbalanced. Imbalanced or not balanced. Now, if we are to plot this on a histogram, we will see that, and if we are to draw that bear curve for this numbers on a graph, this data is going to be skewed to the right. So we can see that we have more data points at the right than more data points at the left. So if we are to interpret this data, I don't want to bring the interpretation here, right? If we are to interpret this data, if the average person who is not married is in her 20s, then there is something going on. Because 18 years, if you are not married, it's fine. 19 years, if you are not married, it's fine. And 20 years, if you are not married, it's fine. And in our society, maybe we are expecting that the threshold to get married is 21 years. And if this is our threshold to get married, or the acceptable age to get married in the Legon community, and we have all these people 25, 27, 28, 29, 33, they are not married, then there is something fishy. So this is when we are going to interpret the statistics well to support our data so it can inform decision making. So we being able to identify the central tendency even first help us to understand either our data is skewed to the left or skewed to the right, and also help us to know how spread our data points are from the mean. So we can see that many people in this community are not married, and they're not married. The age difference from 20 to 33, the range is high. The range is very high. So the 20 here becomes our central tendency. So the 218s, the 218 numbers, and from 21 to 33, so becomes our what measures of spread or measures of variability. The 218 here becomes our the same measures of spread or measures of variability. So meaning this helping us to know what is happening at the left side of our data and this part is also helping us to know what is happening at the right side of our data, hence looking for our measures of spread. And measuring these measures of spread, we said we are going to look at our range, our standard deviation, and our variance. As simple as that. But when we start with the interpretation and establishing each, please, let's do all and go over the previous basic statistics slides. And this video will be shared immediately after today's lesson before tomorrow. So take your time, go over. If you don't understand anything, do an extensive research, come and let's have a thorough discussion. Because I want to take my time to cover this very well because it is going to be the backbone of whatever you are going to do, especially those from non-mathematical background. So please, if you have any question, you can ask. Please, I'm waiting. If you have any question, you can ask. Evelyn, any question? Evelyn, any question?
No.
Oh, okay. So we will share the video right after, maybe by 10, 11, we will share the video and take time.
Hello.
Yeah, hello.
Hello.
Yeah, hello.
Please, can you hear me?
Yeah, I can hear you.
My network, I'm having some problem, but I want to add more to what we have learned so far.
Okay.
Hello.
Yeah, I'm listening.
Okay, so I don't know whether you've talked about that one. So if maybe you have talked about that one since I left and I later came. Okay, so then you prompt me. Okay, so with the central tendency, we have you mentioned the mean, median, and the others. So,
Yeah.
and we also know that with the mean, we sum and later we divide by the values, and so
Yeah.
we can say that the outlier, if there are some outliers or an outlier in the data set, it mostly affect the mean
Yeah.
as compared to
Yeah. So I
okay.
think
Okay.
yeah, what you are saying is right. Right. That's why I didn't even eat into that part.
Okay.
Because we first have to know when to bring in our central tendency, right? And when to bring in our measures of spread. And what does they even mean on a data? And after that, today we assume everyone has a basic concept on data. Then we eat into, because most of us do not even know what an outlier is, right? Then
Okay.
we look specifically into that.
All right.
Now eat into our tomorrow's section.
All right.
Yeah, so thank you very much. Yeah, I think what you're saying is very true. Very, very true.
If you know that you entered all that you need to enter, then there is no need.
So,
If you know that you made a mistake.
Evelyn, we'll meet tomorrow. Okay. So the videos, we will share them before tomorrow and you can go over them. So please, you can also do your extensive reading, get clear understanding. So tomorrow we can share them together.
The Bluetooth device is connected successfully.